Glenn, if you can introduce yourself, we really appreciate you coming on.
Okay. All right. Well, I'm Glenn Berry. I work for SQL Skills. Work for Paul Randall and Kimberly Tripp. And again, I apologize for being late here. It was all my fault. So anyways, what I'm going to talk about today is analyzing I/O subsystem performance. And just a little bit of marketing before we get too far into this is a little bit about me right there. And probably the most important takeaway from this slide is that I've been on Twitter for a long time and I've been blogging for a long time. So if you want to read more stuff that I've done, those are two good avenues. And if you're not on Twitter, by the way, I highly advise you to give it a try. It's not something that you just only use to waste time. It's actually a really good career resource and a way to link up with other people in the SQL Server community. And so moving on from the marketing here, what we're going to talk about today are there's basically three main metrics that you want to look at when you're looking at storage performance. And then I'm going to show you how to look at some specific SQL Server I/O workload metrics to see what your current workload is doing from an I/O perspective. And I'll talk about some of the free tools that are out there you can use to test your storage subsystem. And I'll talk about the 5 primary storage types that are typically used for SQL Server. And then I'll talk about how to choose storage for different types of workloads and different file types, such as data files and log files and tempdb. And I'll talk a little bit about how RAID levels and how your SQL Server workload will affect what RAID level you might want to choose. And then I'll show you some comparative storage metrics for different kinds of storage. So jumping right in here, the 3 main metrics for storage performance are latency, which is typically measured in milliseconds, and then you have input-output operations per second, or IOPS, and those are the 2 that most people tend to focus on, especially SAN people and a lot of IT-type people. But the other big one is sequential throughput, which is sometimes megabytes per second, but if you've got a good system, it's gigabytes per second. And those are really important to SQL Server. But all 3 of these measurements are related, and you can't just look at one in isolation without knowing what the other ones are. And the storage vendors tend to pick the one that makes their system look the best and not talk too much about the other ones. So, for example, SAN vendors like to talk about IOPS, but not so much about latency and definitely not so much about sequential throughput, for example. So latency is basically just the time that it takes for an I/O to complete. And sometimes it's called response time or service time, depending on what tool you're looking at. But it starts when the OS sends a request to the drive and ends when the drive finishes processing the request. And the read is complete when the OS receives the data, and the writes are complete when the drive tells the OS that it has the data. And the data might still be in some sort of a cache, whether it's a hard drive cache or a RAID controller cache or a SAN cache, when that actually occurs. And so that gets into the next thing, which is write-back caching versus write-through caching. And write-back caching is a lot faster, but it's a little bit more dangerous. So you want to make sure you've got a battery backup for your cache if you're going to use write-back caching. And if you have the right kind of hardware, you definitely want to use write-back caching. It's a big, big difference in performance. Now, input-output operations per second, or IOPS, that's related to latency. And basically, it just means how many IOPS per second, how many IOs per second you can process with a queue depth of 1. And as more IOs are added to the queue, like you see with the typical server workload, latency tends to increase. And that's one reason why flash storage is so much better for IOPS, because it can read and write to multiple NAND channels in parallel, and there's no moving parts like you have with traditional magnetic hard drives. And so basically, IOPS is the queue depth divided by the latency. And IOPS by itself doesn't consider whether the transfer is a 4K transfer or an 8K transfer, for example. So you need to know that when you're looking at it. And you can translate IOPS to megabytes per second and megabytes per second to latency if you know the queue depth and the transfer size. So this is really my favorite one for SQL Server, sequential throughput. And again, if you've got a typical system, we're talking about megabytes per second, but a really good system is gigabytes per second. And for example, you can take the throughput in megabytes per second. That's just the IOPS times the transfer size. So here's an example. 292 megabytes per second might be 71,000 IOPS with a 4K transfer size, and that would, you can just do the multiplication and figure that out. And what I've found in my career, and especially a lot recently, is that sequential throughput quite often gets shortchanged with enterprise storage because you've got some sort of a bandwidth limitation, whether it's an HBA or your RAID controller, that throttles that pretty severely. So a classic example that a lot of people are having to still deal with is 1 gigabit per second iSCSI NICs with iSCSI SANs. Hopefully not too many people are still stuck with those, but you only get about 100 megabytes per second, which is less than a single laptop hard drive can do for sequential throughput, and that's really pretty sad. Then some people might have a 4 gigabit per second fiber channel HBA, and that's only going to give you about 400 megabytes per second. And this comes into play in a lot of things that we do every day as DBAs. So full backups and restores, creating indexes, doing index maintenance, and then if you've got a reporting workload that does a lot of large sequential reads, that's going to affect that also. So, the importance of sequential throughput, again, I'll spend a little bit more time talking about this because when you do a full database backup or restore, does it take minutes or are we talking hours? And that can be a big deal in normal usage and also in a disaster recovery situation. How long does it take to do that? And if you're limited to 100 megabytes per second, that's going to make almost any database backup or restore take a long time. And there's things you can do to try to speed this up. So make sure, if you haven't already done it, that you've enabled the perform volume maintenance tasks. And how you do that is you grant that right to the SQL Server Service account so it doesn't have to go through and zero out a data file after it's created or when you grow it. Also, you want to make sure to use backup compression, whether it's native backup compression or a third-party product. And then you also want to keep your VLF counts and your log files under control because that's going to make recovery take a lot longer when you do a full restore of a database. And it also does some other bad things. It makes your instance take longer to start up, and it makes failovers take longer when you go from node to node. Another place where this comes into play is just creating an index. I can't tell you how many times where I've found a really juicy missing index on a really big table. And if I know I can create that index in just a few minutes, I'm much more likely to want to do it and just try and see if it helps out my workload. Whereas if I know it's going to take an hour or 2 hours to create an index on a really big table, then that's going to inhibit me from experimenting and doing better tuning as a DBA. So having really good sequential throughput just comes into play a lot. And when you are going to create an index, you want to make sure to use the max stop option on your index create statement because you can set that max stop equals 1, so then you only have one processor core building the index, and that's going to probably make it take longer, but it won't hit your system as hard, and it won't create an overload on your I/O subsystem. So I do that when I build indexes and when I rebuild them a lot. And then make sure to think about data compression. Data compression is enterprise only, obviously, but it can be a big win in a lot of scenarios. And then finally, big data warehouse type large sequential scans. If your database doesn't fit completely in the buffer pool, then having really good sequential read performance is key. And one thing that can help a little bit is buffer pool extensions. It's really meant more for OLTP reads, but it helps a tiny bit for data warehouse reads, although Microsoft kind of decided to not let it help very much. And I wish they would let us tune that because sometimes it would come in really handy to be able to use BPE. So, the next thing I want to talk about is just SQL Server I/O workload metrics. And what you want to try to figure out, both with your existing system and looking at a new system, is what is the read versus write ratio of your workload. And you can use my DMV diagnostic queries to help determine this. I can tell you at the file level how many reads and how many writes you've had since the instance has been running. And that helps you figure out, is it more of an OLTP workload or more of a data warehouse workload? And whether you've got things in play that are reading the transaction log, like replication, for example. And these ratios are going to be different for the different file types and the different workloads you're going to run into. And the next thing you want to know is what are your typical I/O rates in terms of IOPS and throughput? So then here, perfmon is your friend. You can look at reads per second and writes per second in perfmon, and that's IOPS. And you can do the same thing for disk read bytes per second and disk write bytes per second in perfmon, and that's throughput. And then finally, you can look in perfmon at the average disk seconds per read and the average disk seconds per write, and that tells you your latency at the file level. Well, actually, in Perfmon, it shows you at the logical disk level. But then you can use my DMV queries to go into the file level and see for each data file and each log file for all your databases what their read latency is and what their write latency is. And this is the kind of stuff you want to gather up when you're trying to figure out if you have an I/O problem or not. And when you go talk to your SAN administrator about, hell yeah, it looks like I do have an I/O problem. And of course, usually when that happens, they look at their SAN for a couple minutes and they say, oh, the SAN looks fine to me. Hopefully people have probably heard that a few times. So having all this evidence that you've gathered from the OS level and from SQL Server is what you want to have before you have that conversation. So some of the things you can do to measure I/O performance. Task Manager, if you've got Windows Server 2012 or newer, and depending on what kind of storage you're using, you can see some I/O metrics live in Task Manager. And then you can look in the disk section of Windows Resource Monitor and get a lot of really good metrics in real time. And those are both very quick and easy to use, assuming you can RDP into the server and see them. You can also look at the logical disk counters that I mentioned on the previous slide in Perfmon. So those are all OS level tools that are built in, that they're free. And then you can download these three tools that I have linked below. You've got Crystal Disk Mark, which is written by a developer in Japan, and it's on a kind of a scary website with lots of flashing things. So some people go there and they think it's something bad, but it's actually a very easy, safe tool to use. And then SQL.io, most people are familiar with that, and they might not have used it, but they've probably heard of it. And despite the name, it doesn't require SQL Server and doesn't use SQL Server. It's just a way of stressing your disk subsystem. And then finally, a new one that probably a lot of people haven't heard of is called Disk Speed, and it's another Microsoft tool that's much more powerful than SQL.io, and you can use it in a similar way but get better results out of it. And then finally, my SQL Server DMV diagnostic queries have a lot of I/O related queries, and I'm going to show those to you in a few slides here. So, here's what Task Manager looks like in Windows Server 2012 and newer. And depending on what kind of storage, you may or may not see this information. For a lot of types of storage, you won't, but always look there and see if it's going to be exposed. And then here's what the disk performance looks like in Resource Monitor. And what's interesting about this, to me at least, is that you can sort these columns by reads and writes, and also you can sort by the response time. And this goes down to the individual file level. So you can look at, okay, this data file on the H drive and see how many reads and writes that it's seeing and what its latency is. So it's a good, quick, and dirty way of looking at it in real time. Then here's the logical disk counters that I like to use in Perfmon. And all these ones that are highlighted here are the ones that I think are most valuable. And then we're going to jump out of PowerPoint temporarily and pull up Management Studio. All right. So can you see Management Studio here?
Yes.
Okay, great. So this is just a subset of my complete DMV diagnostic query set. And some of the queries I'm going to show you in this set are SQL Server 2014 only, but most of them are work on any version. So anyways, the first thing I like to run is DBCC trace status, -1. And that shows me all the global trace flags that are enabled on this instance. And the key one that I'm looking for from an I/O perspective is 1118. And that affects how extents are allocated in TempDB. And really, there's no reason not to have this turned on. I think every single instance in the world should have this turned on. It just makes TempDB work a little bit better. And then 2371 is not really I/O specific, but it has to do with how often statistics are updated automatically on large tables, so it can indirectly affect I/O. And then 3226 is just one that suppresses the logging of successful backup messages to the error log, and it really is not I/O specific, but it's something that I think everybody should have turned on. So the next one that I want to run is I want to have just a high-level idea of what kind of hardware I'm running on, how much memory I have in the box. So, on my workstation here, I've got one CPU, and I've got 8 logical CPUs, and I've got 32 gigs of RAM. And then I can look over here and see a few other things. And right here, I want to know, when did SQL Server last start? And then also over here will tell me if there's a hypervisor on the machine. It doesn't mean I'm running inside of a hypervisor, it just tells me whether there's a hypervisor on the machine. So next I want to find out how many sockets I have and how is it licensed. So this is something that's in SQL Server 2012 and newer, this little licensing message. And what's important here is it tells you your socket count and your physical core count and your logical core count, and then it tells you how many SQL Server is using over here. And I've run into a lot of people lately who have gone out and bought a brand new big server, and they run SQL Server 2012 or 2014 Standard Edition, which has a limit of 16 physical cores or 32 logical cores or 4 sockets, whichever is lower. And they bought a server that has more than that. So then they don't realize that SQL Server is only using a portion of their available cores until they run this query, and it says right there, you know, you've got 48 cores, but I'm only using 32, buddy, so that's kind of bad. And what's even worse is that when that happens to you, it doesn't spread the cores across your Newman nodes evenly necessarily. So that's something you can fix if you run into that. And then going on to the next query, this shows what processor you have. And I really want to know that as a DBA because it kind of gives me an idea of how old the hardware is and whether I've got a good processor or not. And also, knowing the processor is actually important from an I/O perspective because only certain newer Intel processors have PCIe 3.0 support, which has double the bandwidth of PCIe 2.0. And so knowing the processor, and this is the only way you can find it from T-SQL, is really important from that perspective. All right, now the next query I want to run from this little subset is a subset of SP configure, basically. So I want to find out, is backup compression default turned on? It should be, in my opinion. I want to see if this has been changed, cross threshold for parallelism. I want to see what max stop is, and I want to see what max server memory is set to. And then finally, optimize for ad hoc workloads. I think that should be enabled pretty much for everybody, but I want to know whether it's enabled or not. So the next one is I want to find out is buffer pool extensions enabled. And in case you don't know what that is, that's a new feature that was added in SQL 2014. And it lets you set aside some space on some flash storage, and it lets you use that as a clean cache. So you can read stuff off of your regular I/O subsystem and then write it to that cache, and then the next time it'll look in that cache. And the idea is that if you've got fast flash storage, theoretically that can give you much better performance than having to go out to your real I/O subsystem to get it. And anyways, Microsoft put this in, and it actually works in Standard Edition. So you can see from here I've got it enabled on my workstation, and it's taking up 64 gigabytes on my L drive. And then if you do have it in play, you can run this query, and it'll tell you whether or not it's being used. And it probably won't be on mine because I didn't have time, unfortunately, to prime the pump for this demo. But it would show you which databases were actually using the BPE file and how much space they were using. So the next one on this query set is going to show me the file names in the past for all of my database files on the entire instance. So it's going to show me the data file and the log file and where they're located. And it's also going to show me some interesting stuff like is percent growth enabled, which is bad. You don't ever want to use this percent growth. It shows you what their growth is set to and then how big the files are. So running this on a server helps me figure out how are my files spread across my I/O subsystem. You know, what drives are they on and how many drives do I have. Now the next one is going to tell me how big are the volumes on my system that have any SQL Server database files on them. So I've got some stuff on my C drive and some stuff on my L drive, and it tells me how large they are and also how much space I have available. And having lots of free space available is very important for performance with magnetic drives especially. You may or may not have heard of a term called short stroking, and that means you purposely only use maybe 20 or 30% of your space because on a regular magnetic drive, the data is on the outside of the platter when it's filling up. And so if it's on that outside of the platter, the arm that has the head that reads the data doesn't have to move as much, and you get much better performance if that's the case. But as it gets more and more full, it has to move a lot further, and so you lose performance. And you have a similar effect with flash storage. As flash storage gets more and more full, performance tends to go downhill because it's harder for the drive to do garbage collection and cleanup that it has to periodically do. So it's also a good idea to have a lot of space on flash storage for a different reason. So the next query here is I want to find out if I've got any of those evil 15-second I/O warnings in my error log. And hopefully I don't on my workstation, but on a lot of real servers, if you're seeing really, really poor I/O performance, you'll see these 15-second I/O warnings in the error log. And when you see that, you want to look and see if there's any kind of a pattern there, because it may be that every night at 3 a.m. when you're running CheckDB or when you're rebuilding your indexes, you see 15-second I/O warnings on certain files. Or maybe you're just seeing all the time, which is really, really bad. But this is a good piece of evidence. This is basically SQL Server screaming bloody murder that it's really, really waiting a lot for a long time on I/O. So the next query I want to show you is the drive level latency information. And this is since SQL Server's been running, and this shows you the latency for all of your files. And this includes everything that's happened for your database-related files, so backups and restores and index maintenance, plus your regular workload. And since I haven't done anything significant on my workstation today, there's not any interesting stuff here, but in real life you would see the read latency and the write latency here, and also how large your reads and writes are for these. So moving on, you can do the same thing at the file level, because that was the drive level. So this would let you drill in and see your individual databases, and you can see which ones have the highest read stalls and the write stalls, and then you can see what file we're talking about here. And so this also gives you some information about the number of reads and the number of writes to each one of these files. So this helps you start to figure out, yeah, this is more of an OLTP workload or more of a data warehouse workload, for example. All right. Almost done with this. The next one is VLF counts. And VLF counts are basically every time you grow your transaction log file, your VLF count grows by a certain amount depending on how large the file growth was. And they changed the formula for this in SQL Server 2014. So Paul Randall wrote a really good blog post about a month ago that explained this. But on 2012 and earlier, they used the same formula. And basically, you want to try to avoid lots of small growths. You want to have a fewer number of larger growths to keep your VLF count under control. And when the VLF count gets high, it affects the write performance to your transaction log files, but more importantly, it affects the recovery portion of database restore. So when you're restoring from a full backup, it's going to take a lot longer to do that. And it also affects crash recovery. So when you start your instance and all your databases go through crash recovery, or you fail over from one node to another in a failover cluster, this affects how long that takes. So keeping this under control is a really good idea. Now the next query is going to show me the I/O utilization by database across all my databases. And so I've got, only about 7 or 8 databases on my workstation, but it shows you how much I/O they've done and the percentage. And this would be more interesting on a real server, but it helps you figure out which database is using the most I/O. Now the next one that I want to show you is the infamous, I call it cumulative weight stats query. And the reason why I say this is infamous is because this is really easy to misuse and misinterpret. And if your server's running really well and nobody's complaining about anything, I don't want you to spend all night agonizing over whatever the top weight type is, because SQL Server is always waiting on something. But if your server's under stress and things are not running well, then looking at the top cumulative weight type can be a useful hint that, okay, this might be an I/O problem or it might be a CPU problem. But you also want to do some research and use your judgment. Don't just go find the first blog post you can find that says, oh, if you have high CX packet weight, you should set max stop to 1, and that'll fix the problem. There's lots of bad information like that out on the internet. And Paul Randall is going to be doing a lot of work in this area pretty soon to document all these weight types and tell you whether or not you need to worry about them or not and what to do to fix things when you see a certain weight type. So the next one that I like to run is this one that gives me the average task counts across all my schedulers. And you need to run this multiple times when you're under a load, because what you're looking for here is the numbers are going to be changing from second to second, but you want to get an idea of what's going on. And high average task counts quite often mean that you're running into blocking or deadlock type problems, or it could just mean that your system's really, really busy. And if you see it above 10 for a sustained period, that's usually reason to worry a little bit. Average runnable task count means that it's waiting for CPU time. You've got tasks across your schedulers that are waiting for CPU time. So that's usually a good indicator of being under CPU pressure. And then the last one is pending disk I/O count, and that's kind of obvious. If you're seeing that above 0, that's a good indication that you're under some I/O pressure. So, running this fairly often is a good idea, and that's one of the first things I want to run when I see a system that's struggling. I'll run this to see, okay, is it blocking, is it CPU, or is it I/O? All right. The next one is page life expectancy. And page life expectancy is basically how long something stays in memory before it has to get flushed back out to disk. And higher values are better here. And there's an old value from 10 or 15 years ago of 300. People say, oh, if it's below 300, it's bad. And if it's above 300, it's good. Well, that's nonsense anymore. It depends on how much memory you have on your machine, and it depends on your workload. And what you want to do is just watch the trend and watch your range, because it's going to change at different times of the day, and even when certain queries are run, it'll make your PLE go lower. So just having an idea, oh yeah, my PLE is between 5,000 and 10,000 typically. So if you know that, and then you look at it and it's 0, then you know something's going on and you're under memory pressure. So that's what I like to do when I look at this. And then the next one, you've got to be on a specific database to make this interesting. Of course, since I didn't prime the pump, it won't be that interesting, but you go to the database you're worried about, and then it shows you for the data file and the log file, the number of reads and the number of writes, and the percentages, and then also the megabytes read and written. So again, this helps you figure out your workload from an I/O perspective. So those are all a subset of my diagnostic queries that are mostly I/O focused. And before I jump out of this, I want to point out this one article, excuse me, right here, that Microsoft published late last year. It's called Recommended Updates and Configuration Options for SQL 2012 and 2014. And here's the URL for it. But it gives you a lot of really good information about trace flags and configuration options that you should set to make sure that your workload runs really well. And they come right out and say, yeah, you should probably keep up to date with cumulative updates. And I know there's a lot of controversy about that. Some people don't touch cumulative updates, but this is a good resource that I highly recommend. So I'm going to jump back into the PowerPoint here in just a second. All right, so we were down to here. All right, so after you've run that set of queries, some of the things that I typically see when I run those is it's pretty common to see very high write latency to your tempdb data files. I see that all the time. And so if you're seeing that, some of the things you want to do is make sure you have multiple data files. The latest guidance from Microsoft and Bob Ward is to start with maybe 4 to 8 data files and make sure they're all the same size and they all have the same auto growth. And then make sure you're using that trace flag 1118 as a startup trace flag. And you also might want to consider using local flash-based storage for TempDB. And if you're on SQL Server 2012 or newer, and you're using a traditional failover cluster, you can move your TempDB off of your shared storage to be local on each node in the cluster. And I've had a lot of customers do that recently with really good results, and it's not very expensive to do. And you get better TempDB performance, and you also take the TempDB load off of the SAN, so the rest of the system runs better too. So it's something that a lot of people are doing lately. It's also very common to see very high read latency from your user database data files. So if you see that, I look for signs of memory pressure such as low PLE or high memory grants pending. And if you see that, the first thing I'm going to think about is maybe adding more memory. You know I get accused of throwing hardware at the problem, but hardware memory specifically is cheap. And a lot of times, adding just a little bit of memory for a couple $1,000s or less can have a huge effect on your workload. And of course, you also want to do all your standard workload query and index tuning to help reduce the memory pressure, because having lots of memory pressure puts more pressure on your I/O subsystem, especially for reads. And then you also might want to try out SQL Server buffer pool extensions, especially if you have Standard Edition, because SQL Server 2014 Standard Edition has that 128 gigabyte memory limit, which is still ridiculously low in my opinion. You know, that's only about $1,000 worth of memory, which is ridiculous. But if you've maxed out your memory, and you don't want to just have 128 gigabytes, by the way, you might want to have 192 on the box, so you can give all 128 to SQL. And if you've already done that, then you might want to try BPE, because it might help you in this kind of situation. But anyways, after you've run all these queries and you've looked at perfmon and you looked at resource monitor, gather all your evidence to show your SAN administrator or your storage administrator, because the overall SAN metrics may look great. And so you've got to have as much data as you can showing that SQL Server seems to be running into I/O bottlenecks. And also keep in mind that the Subsystem I/O virtual file stats are cumulative since the instance was started. So if the instance has been running for several months, you need to take that into account. And they include everything that's touched your database files. So Crystal Diskmark is a free tool that's really easy to use. You know, even Dilbert's pointy head boss can use it. All you got to do is push a button and watch it for a few minutes. It does have a few configuration options. The first thing you want to make sure to do is test with a 4,000 megabyte test file. And that's going to minimize the influence of your hardware cache. You know, if you use a smaller test file, it might fit completely in your cache. And you also want to make sure to have it do 5 test runs. You can pick anywhere between 1 and 9. And the more runs you take, the longer it takes to run a test. But if you just run 1 or 2, it might not be quite as reliable with the results. And also, you want to do a test with random and non-random test file types. You can pick that from the menu. And the reason why you want to do this is that random data is not compressible. And the reason why this matters is some SSD controllers use write compression to get better performance. And if the data is not compressible, then you're not going to see the performance that you expect. And where this comes into play with SQL Server is if you're using backup compression or if you're using data compression, then your data is already compressed before it gets written to the disk. And if the controller tries to compress it again, it's not going to compress it very much. And then finally, when you run this test, it's going to show you megabytes per second for the 4K random I/O, and you can multiply that by 244, and it'll show you the IOPS, or you can hover the tooltip. And then there's another trick that I learned not that long ago, to be honest, that you can Control-C on the GUI and then paste it in a notepad, and you get the full detailed results in text, which can be easier to work with. So here's what Crystal Diskmark looks like. And what you want to focus on here is the top row where it says sequential, and then the bottom row where it says 4K Q depth of 32. And that text box in the bottom, you've got to type that information in yourself. So this lets you test any drive letter that you can see from the OS, whatever might be behind it, you're testing that LUN. And so you have to know what it is you're testing. You type it in the text box, and then you tell it to do 5 test runs in a 4,000 megabyte test file and pick whether it's random data or non-random data, and then you click on the All button, and then you wait about 5 or 6 minutes, and then it comes back with the results. And these results, by the way, are excellent. This is a 2 terabyte Intel PCIe storage card that's not that expensive. This particular card is about $6,000 or $7,000, but it's amazing performance. This performance will smoke most SANs out there for a fraction of the cost. So this is what you want to look at, and you can highlight this thing and do Control-C and then Control-V into Notepad and get all the results in text format if you don't like pictures. So this is what it looks like in text format for that exact same test. And it shows you the IOPS over here to the right. So that's kind of nice. And it also shows you the OS and when you ran the test. So that's kind of nice. Moving on, SQL I/O. You can do this, and of course, as I said earlier, it doesn't require SQL Server. So what I always do is as soon as the OS is installed and I've got my LUNs provisioned on a new server, I'm going to run SQL I/O after I run Crystal Disk Mark. And it's a little bit harder to use, and it takes a lot more time. And it can be dangerous because you can use SQL I/O and just hammer a storage subsystem so badly that it falls over. So be careful with SQL I/O. It's a little bit more dangerous than Crystal Disk Mark. And you can use an old-style command prompt, or you can use PowerShell if you're a PowerShell junkie to run your SQL I/O tests. And Jose Barreto is a guy who works for Microsoft on the storage team. He has a really, really good blog, and so I've got several of his blog posts highlighted here, and this is one of them where he explains how to use SQL I/O and PowerShell to do really good testing. So then the next one is disk speed. And it's a new tool that came out from Microsoft late last year that gives you a lot more flexibility than SQL I/O does. And it can be done with PowerShell also. So here's another blog post that explains that, how to use disk speed in PowerShell to do all sorts of really deep testing. So the primary storage types for SQL Server, jumping to a little bit different part here, are internal drives, direct attached storage, storage area networks, PCIe flash-based storage cards, such as that Intel that I showed you, and then SMB file shares. And you might think, oh, that's crazy. I would never put my database files on a file share. Well, you can do that now if you've got the right hardware and you've got Windows Server 2012 or newer and SQL Server 2012 or newer. You can use and get really good performance for a very low cost. And this has been very popular in the virtualization world. You know, the Hyper-V people have been doing this for years. But now it's starting to show up in the SQL Server landscape, and I think it's going to get more popular over time. So going on, internal drives, with modern servers with 2.5-inch or even 1.8-inch drives, you can get a lot of drives, even in a 2U server. So you might have anywhere from 8 to 28 drive bays on a server. And if you're using flash drives, you can get a lot of performance out of those. And if you're going to do this, you want to make sure that you use the very best hardware RAID controller you can get. Because usually when you go to buy a new server from Dell or HP or somebody, you've got 3 or 4 or 5 different RAID controllers you can buy. And the higher-end RAID controllers have much faster processors, and they have more cache memory, and they're not going to become a bottleneck as quickly as the very cheap RAID controllers. And there's not that much of a cost difference. And so it's important that you pay attention to that. Now, with direct attached storage, typically what's going on there is you've got one big storage enclosure with multiple drive bays, and then you have a direct connection to your particular server. And what I always try to do here is have at least one RAID controller for each storage enclosure, and sometimes I might have 2 RAID controllers for each storage enclosure because I don't want the RAID controller to become a bottleneck. And one thing I try to avoid is something called daisy chaining, where you have a RAID controller that connects to a DAS enclosure, and then you hang another one off of that. And so you have multiple enclosures off of one poor RAID controller. So the RAID controller can become the bottleneck, or the PCIe slot that it's plugged into can become a bottleneck. And then the thing about direct attached storage is it's pretty easy to configure and manage. And it doesn't require any special training or expertise. It does require some planning and common sense because it's harder to change things than it is with a SAN. But what's so nice about direct attached storage and internal drives is you can get really, really good sequential read and write performance. Typically, your limit is going to be your PCIe slot or your RAID controller in some cases. So direct attached storage, again, try to use one dedicated RAID controller or sometimes two, and use the best RAID controller you can get, and then finally make sure that the hardware cache is enabled. I've run into a lot of customers where they went out and got a nice RAID controller, and then they, especially for Dell customers for some reason, but they used the Dell OMSA tool to set up their logical drives. And when they did that, what happened is, by default, the cache is disabled. And so they've got that nice RAID controller with a big cache, and they're not even using it because the cache policy is disabled. So when you're doing this, you want to also pay very close attention to your PCIe slots that you have these devices plugged into, because on an older server, this can be a big bottleneck. And I've seen a lot of people who have been bitten by this, especially with PCIe storage cards like Fusion IO cards, for example. And finally, you want to make sure in most cases to dedicate the hardware RAID controller cache to writes instead of reads. So sometimes that means you have to disable read-ahead caching in the RAID controller, because the SQL Server buffer pool is a much better read cache than the little tiny hardware RAID cache on your RAID controller. And usually you're having more problems with writes than you are with reads from an I/O perspective, so you want to try to use that hardware RAID cache for writes if possible. So storage area networks, this is a big external system with lots and lots of components. You've got anywhere from dozens to hundreds of hard drives. You've got storage processors, a big cache, its own operating system. And SANs are usually very expensive. And then when you exhaust the space on the SAN, it's expensive to add more capacity. And it also requires some training and experience to really set up and use effectively. And of course, the joke I always tell is that cranky SAN administrators are often included free of charge with a SAN. DBAs and SAN administrators don't usually get along that well, so that always gets a laugh from DBAs. But there's two main types of SANs. There's fiber channel SANs that use HBAs, and then there's iSCSI SANs that use dedicated Ethernet cards. And you can also have sort of a combination of the two. But SANs are typically optimized for IOPS. They've got dozens to hundreds of hard drives, and they've got a big cache in front of them, so they can give you lots and lots of IOPS. But where they're usually limited is their sequential throughput, because whatever they're using to connect to your host, and then all the switches and other ports in between, that's what's going to be your limiting factor for sequential throughput. So again, the bad example that a lot of people are still stuck with, although not as many as it used to be, is a 1 gigabit per second iSCSI NIC. And that's only going to give you about 100 megabytes per second, roughly, for each connection. And that's pretty bad by modern standards. So again, with a SAN, even though we don't like each other, try to befriend your SAN administrator. Really communicate with them and tell them what kind of a workload. Don't just say, well, I need 5 terabytes of space on the SAN. Go and talk to them and say, well, this is going to be a SQL Server OLTP workload, and we really need a high level of RAID for the log files, and we need this for the tempdb files, and talk to them about your workload and share the metrics you've gathered from your existing workloads, if at all possible. And keep in mind that they have different priorities than you probably do, because they've got multiple servers sharing that SAN with different workloads. And he has to worry about running low on space and having to go to the CIO and beg for more money to get more space. So they're always worried about space. And then they've got all those cranky DBAs complaining about the performance. So when you're looking at a SAN, look at the complete data path, so the HBA or the NIC and all the switches and the SAN ports. Make sure there's not something in the middle that's artificially throttling your performance. And also, just be prepared for inconsistent performance with a shared SAN. When other people, other hosts, are hitting that sand hard, it can affect your workloads. You'll see different performance at different times of the day and different days of the week. And finally, keep in mind that sands are not magic. No matter what the sand vendors and the sand salesperson likes to say, the details of the hardware, is it 10K drives or 15K drives, is it flash drives, they still matter. And again, sands are typically throughput limited, which I don't like for SQL Server. I want lots of throughput for my SQL Server workloads. So PCIe flash storage, that's just flash-based storage on a PCIe expansion card. It looks kind of like a video card or a NIC. It uses a very high bandwidth PCIe slot instead of a SAS or a SATA port, so it has a lot more sequential bandwidth. And the latest products that have been hitting the market in the last year or so use non-volatile memory express, NVMe, to give you really, really good performance, very low latency. And it's very important with these kinds of devices that you pay attention to what slot they're plugged into, what PCIe slot, and whether it's a PCIe 2.0 or 1.0 or 3.0. And this X16 or X8 or X4, that means how many lanes are in that PCIe slot. And higher numbers are obviously better in this case. And anyways, these kinds of cards can give you really high I/O performance. The top of the line ones can give you almost 7 gigabytes, not gigabits, but gigabytes per second of sequential throughput. And the highest end ones can also give you over 1 million IOPS. So that just will annihilate your average SAN. Of course, the really high-end cards like this are quite expensive, but some of the more affordable cards are getting higher up in the performance now. So again, that Intel one that I talked about earlier gives you quite good performance for a fairly low cost. And you can get even smaller ones for less than $1,000 that can do things like maybe your TempDB workload, for example. And it's very common, and it's a good idea to use 2 of these in your server instead of just 1, and then use software RAID 1 at the OS level so you have some redundancy instead of just running it on the single card. And one advantage of these things is they use a lot less electrical power than having dozens or hundreds of hard drives, which can save a lot on your electrical costs and your cooling costs and your rack space in the data center. And here's the PCIe slot bandwidth limits that I've alluded to a few times. If you've got a server that's maybe 5 or 6 years old, it's a pretty good chance that it has PCIe 1.0. So in a worst case scenario, with an X4 slot with only 4 lanes, that means the entire slot can only do 750 megabytes per second. So if you plug a card in there that does 2 or 3 or 4 times as much as that, then you're going to be throttled by the slot. So if you've got a server that's maybe 2 or 3 years old, you probably have PCIe 2.0, and the bandwidth doubles there. But where you want to be is PCIe 3.0, and that doubles the bandwidth yet again. And unfortunately, at this point, only the Xeon E5 and E5 V2 and E5 V3 for 2-socket servers, and then the E7 V2 have this. So if you have an E7 without the V2 or something older than all this, you're going to be stuck either here or here. So that can be a big deal, and another good reason to try to upgrade your server. So SMB 3.0 file shares. If you've got Windows Server 2012 or newer, you can use this. And you also need SQL Server 2012 or newer. And it lets you store both your user and your system databases on a file share. Now, you can do this with any kind of hardware you want, but if you just use your garden variety gigabit Broadcom NICs that are built on your motherboard, you're not going to get the kind of performance that you need. What you really need is something that supports something called Remote Direct Memory Access, RDMA. And that's going to be a special kind of NIC or something ideally like InfiniBand that gives you really low latency and very, very high bandwidth, so 56 gigabit per second InfiniBand connections. And you can do this so you have multiple file servers that expose file shares, and they can be clustered for redundancy. And you can use this for shared storage instead of a SAN. So if you want to use traditional failover clustering, you can do this with this technology. And again, Jose Barreto writes about this a lot and gives you examples, shows you how to set up a test lab and how to play with this. So it's something you should look into, I think. And one thing I want to point out here is that your database server can be on this side and your file server can be on this side. So both sides of the conversation have to be Windows Server 2012 or 2012 R2 or newer. The next version of the server OS is probably coming out later this year, the server version of Windows 10, and it's going to be even a newer version of SMB, but it's going to default to the lowest common denominator here. So if you've got an old database server that's running on Windows Server 2008, then you're going to be stuck down here on SMB 2.0, and you're not going to be able to use this. All right, so you also want to consider your workload when you're thinking about storage, because SQL Server has several different common workload types, and OLTP is one of the main ones, data warehouse or reporting type workloads, and then OLAP workloads. And it's pretty rare to have just a pure OLTP workload or pure data warehouse workload. Sometimes it's a mixture, but all of these workload types have different I/O access patterns. And an OLTP workload, for example, has lots of writes to data files and also to the log file. And also going to have a lot of reads from the data files if the database doesn't fit into the buffer pool. So in that case, random I/O performance can be very important for your normal workload. But again, sequential performance is still important for things like index maintenance and backups, for example. Whereas a data warehouse workload, it has all those large sequential reads from the data files, so sequential read I/O performance is very important there. And then an OLAP workload is going to have lots of random reads from your cube files, so random I/O performance is very important there. And RAID levels in SQL Server workloads. You need to think about your workload type again when you're thinking about what RAID level to choose, because it's going to affect the RAID level you want to pick out. Now, RAID 10 is better for write-intensive workloads than most of the other RAID levels because it's not parity-based. And what I mean by parity-based, things like RAID 5 and RAID 50 and RAID 6, what they do is they write out the data and then they calculate a parity information and they write out the parity information, so you're paying a price for writes. So if you know you've got a data file with lots and lots of writes, or your transaction log file, which is mostly writes, it's probably not a good idea to use a parity-based RAID level for that. And you've also got to think about your availability requirements, because some RAID levels, like RAID 10, are more robust than other ones like RAID 5. And I know IT people and SAN people like to use RAID 5 and RAID 50 because it's inexpensive and lets them have more usable space, but they're just not as robust as RAID 10 is, for example. And then, of course, the different types of workloads, whether it's OLTP or data warehouse, are going to have different patterns. So the percentage of reads versus writes, and whether it's sequential or random I/O, is going to vary based on that. And also the different file types. So your data files, your log files, your tempdb files, and your backup files all have different I/O patterns depending on what's being done. So you just need to think about all of this as you're trying to decide, well, what RAID level am I going to use for this drive, this LUN, and then am I going to use flash storage or magnetic storage, for example. This all comes into play when you're making these decisions. So selecting a RAID level for your SLA, RAID is not a substitute for a good backup and restore plan. I've had managers come to me in the past and say, well, Glenn, we're using RAID 5 for the data files, so maybe you can stop running SQL Server backups. And that's just ridiculous, but that's a common misconception you might get from your boss. Why are you running these backups? They take up so much space. We're using RAID. Well, that's ridiculous. Don't let anybody talk you into doing that, because RAID's not a substitute for backups, and it's not a substitute for an effective HADR strategy. No matter what any vendor with their magic appliance or product tells you, I want to be running backups and have a good restore strategy. I want to have some HADR in place so that no matter what else is going on, at least SQL Server can take care of itself. All RAID does is reduces the chance of unplanned downtime from losing one or more drives in an array. That's all it does. So RAID 10 and RAID 50 are the most robust, commonly used RAID levels. The problem with RAID 5 is you can only lose one disk in an array before you lose the array. And having more drives in a RAID 5 array makes it more likely you're going to lose a drive. And a lot of times you'll lose one and you'll lose another one fairly quickly, especially if they all came from the same manufacturing lot. So one trick that a lot of old timers use that's still valid is when you get a new server in or you get a bunch of hard drives in, you mix them up so they're not all from the same lot. So then you put them in an array together, and that lessens the chance that you lose two at the same time. And it's also a good idea to use a hot spare, maybe a global hot spare or even hot spares for each array. And also I like to have a cold spare. If I have lots and lots of 600 gigabyte hard drives, I'll buy an extra one and then just have it sitting in the cabinet. So that way if I lose one, I can throw the cold one in there and then worry about RMAing the dead one instead of having to worry about getting a replacement before I lose another one. All right, so choosing storage types based on your workload type. Flash-based storage gives you great random I/O performance. It also gives you better sequential performance, but the difference is not nearly as much. It's only typically 2 or 3 times or maybe 4 times better than a magnetic drive for sequential, but it's orders of magnitude better for random. And of course, flash-based storage is still the most expensive storage per gigabyte, but the price is coming down pretty rapidly. And you need to be careful here, because if you just go to your favorite server vendor like Dell or HP or IBM, they tend to gouge you when you buy flash-based storage. But if you go out and buy something from Samsung or Intel that's an enterprise drive, I've had a lot of customers who they'll buy their server from Dell with no drives in it or just 2, and then they go out and buy the other drives themselves from Intel, for example, and the prices are much, much lower. And a lot of times these storage vendors, server vendors, are selling the same drives themselves and just marking them up. So even if you're afraid to do that, at least threaten to do it when you're talking to your server vendor salesperson, and sometimes they'll give you a price break because they just really gouge you on this. It really makes me mad. So anyways, magnetic storage gives fair sequential performance, but it gives very poor random I/O performance. And one thing that people have been doing for years is just using big controller caches to try to mask that. And something that people have also been doing for several years is using flash-based caching in front of your magnetic storage. So you try to cache some data in your flash-based storage. And caching tends to work better for SQL Server than tiering does. You know, a lot of storage appliances and SANs will try to do automatic tiering where they're moving the hot data from the magnetic drives to the flash storage. And the problem is SQL Server workloads are changing so much that auto-tiering can sometimes just kind of be chasing its tail, trying to move the data around to keep the hot stuff in the flash. And if you just use a caching mechanism rather than trying to do tiering, it seems to work better for SQL Server. So anyways, flash-based storage is always the best choice if you have the budget. But if you don't have the budget to do everything flash storage, then look at where you're doing lots of heavy random I/O, and also look at where you might have bottlenecks. So if you're seeing lots of bottlenecks on TempDB, then maybe you want to use some flash storage. But don't always automatically jump to the conclusion that's what you should do, because some workloads hardly use TempDB at all, and so it'd be a waste of money to have TempDB on flash storage in that case. So configuring your storage for the different file types. For SQL Server data files, it's still most common to use magnetic storage because they're usually very large, but flash storage is starting to get more popular because the cost is coming down. And most people are using RAID 5 or RAID 50, in some cases RAID 10 if they have the budget and if they have a really write-heavy workload. Now, log files, it's still pretty common to use magnetic storage, but I see more and more people using flash for their log files. And most people are going to use RAID 10 if possible. They try to avoid RAID 5 or RAID 50 for log files. And then TempDB data and log files, a lot of people still use magnetic storage, but I think that's a mistake for a lot of people. Flash-based storage is usually a better choice unless you're one of those workloads that doesn't use your TempDB very much. And then if you're using magnetic storage, make sure you're using RAID 10 for your TempDB instead of RAID 5. And then for your backup files, most people, unless they have money to burn, use magnetic storage for that, and usually they use RAID 5 or RAID 50 just because of the economics of it. So HA and DR, they have an effect on your storage choices. If you have a traditional failover cluster, which is old but still good technology, it requires some form of shared storage. And traditionally, that's been a SAN. But now, you can use SMB file shares if you've got SQL Server 2012 or newer. And even if you're using a SAN, it's becoming more common, I should say, to move your TempDB off of the SAN onto each node. Of course, when you do that, you've got to be very careful that your TempDB uses the same drive letter and same path on both nodes. So when you fail over, it's where it expects to find it, and it will start up just fine. Now, always-on availability groups, they have to use the clustering feature, but they don't have to use shared storage. So you can use shared storage if you want, but a lot of people like always-on availability groups because it lets them pick whatever kind of storage they want. So they could use PCIe flash storage cards or internal drives or whatever they want for each node or each replica, in their always-on availability group. And so it gives you a lot of flexibility there. And then anything else you might be using, like database mirroring or log shipping or replication for your HADR, you can use whatever kind of storage you want. And what I always want to try to tell people to do is if you are going to use shared storage, don't make the mistake of having both sides of, say, a database mirror on the same shared storage, or the same way with log shipping or anything else you might be doing. Make sure they're on different storage subsystems if at all possible, so you eliminate that single point of failure. So sizing your storage subsystem, there's RAID calculators online that you can use to make sure you have enough disk space. So, when you know that you've got 24 drives and there's 600 gigabyte drives and it's going to be RAID 10, you can punch those in and it'll tell you how much space you'll have after Windows formats it. And not only do you want to have enough space to make sure everything fits, you want to have more than enough space so you can take advantage of that short stroking. And again, flash storage also benefits from ample free space. So after you have enough space, then you want to concentrate on performance. And I always tell people, don't negotiate with yourself. A lot of times the DBA is afraid to ask for something because they're afraid somebody's going to say no, or they know that the company doesn't have a lot of money to spend, so I'm not going to ask for flash storage. I'm just going to take magnetic and RAID 5, and I'll just deal with it. I think that's a mistake. Look at your workload and do the analysis and build your case and ask for what you really need. And then if you get cut down for budget reasons, then use the information you learned from this presentation to make the right choices. Okay, well, I can't afford to do everything on flash, so I'm going to put my backup files on magnetic, and I'm going to make them RAID 5, and then maybe you give up your data files next, but fight hard for your log files in TempDB, depending on your workload, but go through that. Don't just give away the store without a fight. And then I always tell people, aim for 5,000 to 10,000 or more IOPS on every single LUN. If you've got less than that, that's going to be really bad for most workloads. Of course, more is always better. And then I tell people to aim for 1 gigabyte per second or more of sequential throughput on every single LUN, because that's going to give you really good performance for the things you do every day, like your backups and your index rebuilds and creating new indexes. And it's just so liberating to know that, okay, I've got a 500 million row table or a 2 billion row table, and I can create an index on that table in 5 minutes instead of 5 hours. That's what sequential throughput gives you, that power to do that, and that's really nice. So solid state drives, why they're so fast is that they don't have any moving parts. So the access time, it doesn't matter where the data is located. It's going to be consistent across all the cells. And having those PCIe storage cards instead of traditional SSDs gives you that higher throughput because you're not limited by the SAS and SATA interface, whether it's 3 gigabits or 6 gigabits or now 12 gigabits per second. And they're just really good for random I/O. And we feel at SQL Skills that SSDs are enterprise ready. We used to get a lot of questions 2 or 3 years ago about, well, SSDs are kind of new, and I don't trust them, and I've heard that they wear out, which they do. They have a limited number of writes in them, but the lifetime is so high that it's not really a problem, and I think they're quite reliable now. So magnetic storage versus flash-based storage, just sort of a comparison. Magnetic storage can do typically between 100 and 200 megabytes per second per disk. And Magnetic storage can only do about 100 to 200 IOPS per disk, which is very, very low compared to flash-based storage. Now, flash-based storage, depending on what standard it is, older SSDs can do about 275 megabytes per second, and that's because of the SAS or SATA limitation with 3 gigabits per second. And most of the ones you're probably buying now are 550 megabytes, double that. But the latest ones can do double that, so you can do 1,100 megabytes per second with 12 gigabit per second SAS, so that's pretty decent. But PCIe storage cards can do even more than that, and the very expensive ones can do between 6 and 7 gigabytes per second, but the more affordable ones between 1 and 2 gigabytes per second per card. And of course, where flash-based storage really shines is on random I/O. Your typical SSD can do about 100,000 IOPS, but what you'll find is that enterprise SSDs tend to trade raw performance for longevity and also for storage performance consistency. So their performance is always pretty much the same instead of going up and down a lot like consumer drives would do. All right, so here are just some typical metrics of a typical 15K hard drive versus an enterprise level SSD. And you can see the difference in the latency is huge. The read bandwidth is not that big of a deal. It's about 2.5 times better for the SSD. The IOPS is where it's huge, 90,000 versus 150 to 200. So here's some Crystal Dismark results. So on the left, you've got 2 drives in RAID 1. And on the right is 6 drives in RAID 10. And you can see the numbers going up for sequential throughput on that top line. And then on the bottom line is random throughput with 4K transfers with a queue depth of 32, which is more like a server workload. And those numbers are not really going up that high as you add more and more drives, because each one can only do about 100 to 200 IOPS for each drive. So here's what a consumer SSD might look like. And if you go back and look, the numbers are pretty significantly differently, especially on the bottom row, 3.2 and 4.2 versus 289 and 300. A huge difference for random I/O performance. And even sequential is better, but the difference is only about 2.5 to 3 times faster. And then if you look at some first-generation Fusion I/O cards, these are the 640 gig Fusion I/O Duos from about 3 or 4 years ago, and you can see that their sequential throughput is quite a bit better. It's above that 575 mark because they're not stuck on a SAS port. They're using the PCIe slot. And then if you go to an even newer LSI Nitro Warp Drive card, you can see even better performance here. And what I want to point out here is on the left is with incompressible data, and look at the right performance is 828 megabytes per second, and then over on the right, with compressible data, it's 1,520. And this is one of those particular devices that uses write compression to get better performance. So you might not want to use this particular product if you're using data compression, for example, because, again, the data is already compressed by SQL Server, and then the card is not going to be able to compress it anymore. So here's just a chart to summarize that. So starting at the top from 2 magnetic drives going down to some fairly high performance flash drives at the bottom and PCIe cards. And here's the same thing for random performance, 790 IOPS versus nearly 100,000 IOPS. So a huge difference there. So just to review what I've talked about here, you've got 5 primary storage types. You've got internal drives, you've got PCIe flash cards, you've got direct attached storage, and you have storage area networks. Probably most people have heard of all 4 of those, but now you have SMB file shares that you can use. You've also got the different types of SQL Server workloads that can affect your I/O and how you choose to set it up and configure it. And then the different file types that SQL Server has. Your data files, your log files, your tempdb files. They're going to be doing different things from an I/O perspective depending on your workload and then depending on what you're doing. So like if you're doing a backup, you're going to be doing reads of the data files and then writes of the backup file. So different things are happening at different times with your I/O subsystem. So thinking about all this, you want to make sure to choose an appropriate RAID level for your workload, both for performance and also for SLA requirements, and make sure you don't go down and lose something just because you lost one drive. And then finally, if you don't remember anything else from this whole presentation, remember how important sequential throughput is, because that's going to limit how long it takes to do a backup or do a restore in a disaster situation. Going from minutes to hours can be a big deal in a lot of situations. It just makes your life so much easier as a DBA to have very good sequential throughput. So here's some references, and most of these are from Jose Barreto's blog, at least several of them are. And then finally, if you want to hear me droning on more, I've got a bunch of Pluralsight courses on hardware and my DMV queries and things in this area, so you can go to that URL and listen to them. And anybody who's listened to this presentation, all you've got to do is send an email to Paul Randall and ask for a code, and you'll get a 30-day pass to Pluralsight. So I would urge you to take advantage of that and then hopefully listen to one of my courses so I get something out of the deal. So anyways, after all that, are there any questions?
Any questions, anybody? Okay. Julie, can you grab that one?
Hold on, we got some.
Here.
Hello?
Hello?
Yeah, I've got a few just quick ones. This BPE thing is a totally new thing for me. Can I decide per a database what tables are actually being used by that? Can I control it down to that level?
Unfortunately not. All you can do is you can set aside that space on some flash storage, and Microsoft doesn't even require you to use flash storage. They can let you shoot yourself in the foot and put it on a thumb drive. They don't check for anything, but anyways, hopefully you're not going to make that mistake. You just set aside this space, and the space you set aside has to be at least as large as your max server memory setting. So that's all you can do, is you can just turn it on and decide how big it is and where it's located, but other than that, you have no control, which is sort of frustrating. That's what it is.
My next question is on this flash storage, which seems pretty interesting. What if you've got, let's just pretend you've got one of those $1,000 PCIe cards that works in a 3.0 slot with 16 lanes or something, but your server doesn't have that. Is there some kind of extension box where you could, get a PCIe slot to use that flash card and connect to it, Ethernet or any other?
Well, that would
channel?
I think that would sort of defeat the purpose. I mean, the reason why you want to plug it into the PCIe slot is that you have a direct path to the memory right on the motherboard.
Yeah, I realize that, but if you didn't have that, could you still get into it now? Would it be worth the cost?
Well, I'm not aware of any products that do that, and even if there was a product to do it, I don't think it would be a good idea, because you'd have that bottleneck between the card and whatever you cobbled together to get it into your old server. I would make the argument, now it's time to buy a new server. Servers are not very expensive compared to DBA salaries and SQL Server license costs. You can get a really smoking fast server for $10,000 to $15,000 and not have that problem anymore.
Well, I just remember a long time ago when I was building PCs, there was an extension box that gave me 7 PCIe slots.
Yeah.
I could, connect. But, my last question is on the SSDs. My experience has been, you're always warned about not to ever defrag, and it's really only good to things like OS. Things don't change that often. Can't really think of much in SQL Server world that doesn't change all the time. Is there a worry, since it has a limited lifetime based on the number of writes?
Yeah. Well, I mean, you're right that an SSD is going to wear out and at some point become a read-only device. But you can use the toolboxes that come with the different cards, and they'll tell you how far along you are there. And the lifetime of those things is typically years. Usually it'll be around longer than the server is, unless you're going to keep a server for 10 or 15 years. I don't think it's a big deal like it used to be. They've done a lot of work with wear leveling algorithms and better firmware to try to get better life out of them. So I think they're pretty reliable, but they do wear out at some point. You just have to keep an eye on that if you're worried about it.
Very good point. All right, go ahead, Julie. Unless you have
So I'm one of the lucky ones. They're getting new flash storage for me on a SAN,
Okay.
of which my lovely SAN administrators keep telling me that I don't need separate LUNs. It's just one big happy pool, and it's not going to really matter. And I keep saying, I want LUNs for my database, I want LUNs for my logs, my TempDB, and, well, my TempDB is going local. But I keep asking it to be broken down, and I keep asking for multiple LUNs for my actual database because it's really large. Is that still with the flash storage? Isn't that still the recommendation to split up to multiple LUNs and multiple files?
Well, it's funny, that question seems to come up every time I do a presentation like this. It's a common question, I guess. I probably should talk about it in the presentation, but it depends on the technology the SAN is using. You know, some SANs, what they do is all the spindles that they have or all the flash drives that they have are just aggregated together. And in that case, from a pure technical perspective, it doesn't matter. But even if that's the case, I still like to have separate LUNs so I can see what's happening at the drive level and, you know, with all the different tools that I showed you. It's just a little bit harder if you've got everything on an H drive and that's the only LUN you have. It's a little harder to see what's going on with the different tools. And that's my argument for why I want separate LUNs, even if they're using something that pools everything together like it sounds like you have there. So. But from a performance point of view, it probably won't make any difference.
So, my current system isn't on the flash storage, and we used to use TSM for a backup system, and it had limitations about 1 terabyte per file sizes.
Okay.
So on my database, I broke it up into multiple, MDF and NDFs where they were maxed at the 1 terabyte. Is there a benefit to having the multiple NDF files on these large databases versus just having going to one huge?
No, that's a good question. I mean, I would guess probably 70–80% of the databases out in the wild just have one data file in the primary file group. And I think that's a huge mistake. I think everybody, when they create a new database, they should create another file group and call it main, and then create either 2 or 4 data files. And having those separate data files just gives you a lot of flexibility because then you can decide, okay, I'm going to have 2 data files on this LUN and 2 data files on that LUN, and maybe later on you need to split each data file on its own LUN or add more data files, but it's just better to do that because you get more total I/O performance assuming that these LUNs represent, different storage, not just all aggregated on the same thing. But yeah, I think it's a really good idea to do that for performance reasons. Also, it's easier to do things like file group backups. And if you have to move something, it's easier to move a small file than a really huge file. I mean, there's a lot of reasons why I'd rather do like you've done, and that was a good thing.
So my final one is, so I'm going to be getting new disks, and when you get your new disks, on your server, it's that wonderful allocate your disk and what's the allocation size. You could pick the 4096. There's all those choices.
Yeah.
And if I'm not setting it up, it's like, well, what did you use? And they don't know. So what's the recommendation for the SQL Server for the database and TempDB and those drives?
Well, 64K is a good allocation unit to use. I don't know. I've written a couple of articles about this, but what I should do is point you to them because that shows you some screenshots and goes into a little bit more detail about it. But it's a good thing to think about and check. And also, when they first build a server and provision the disk, make sure you use those tools, Crystal Disk Mark and SQL.io, and to do some testing. Don't just accept it as it comes because you find all sorts of problems, unfortunately, if you don't test.
Yeah, I've used the SQL.io before, but the Crystal Disk Mark looks interesting. And to do that before, I get.
Yeah, you do that before you
people
even
over there.
install
Yeah.
SQL Server. Do it as soon as you have the OS and the LUNs available.
That sounds great.
Anybody else
Okay.
have questions?
Other questions? None? Going once? Going?
Glenn, we really appreciate your time for presenting to the SQL user group here in St. Louis, and for the SQL Skills team for giving the user group, the local user groups, this opportunity to get a top speaker. It's just really been wonderful.
Okay, well, I appreciate the chance to talk, and again, I apologize for being late. Make sure if you want that Pluralsight code to send an email to Paul, and also you can tell him how wonderful I was if you want to, because it'll maybe get me out of trouble here. But anyways, thanks a lot. I appreciate you listening.
And Glenn, what you showed on your management studio, that's on your blog as far as the DMs, or?
Well, what I'll do is I'm going to write a blog post, and I'll zip up a PDF version of the presentation, and it also will have the script that I ran for the demo. So you'll be able to get all that from my blog.
That's great. Just send me a link, and
Okay.
I'll get that posted. Thank you
All
very
right.
much, Glenn.
Okay, thanks a lot.
What was it? Oh, that he needs to hear that. He needs to hear that. Right.